Hi everyone, and welcome to Geometry Lesson 8.6, Vectors. Now, chances are that if you're a fan of animated TV, you've probably heard the definition of a vector from a very famous character. Now, I can't actually play this video clip here, but I have attached it to this assignment. So I'd highly encourage you to watch it. It happens to be one of my favorite video clips. And in it, Vector is going to explain what a vector is. So we're going to start out with some terms. A vector is a quantity that has both length or magnitude and direction. So it's sometimes called a directed quantity because it has a starting point, which we call the initial point, and it has a terminal point or an ending point. And basically, if you were to graph 2 points and draw an arrow from one point pointing to another, that would be a vector. Okay? So it looks like a ray that's graphed. And it has a very specific direction, though. And we can write the vector in what we call component form. It's basically a method of naming the vector that lists the horizontal and vertical change from the initial point to the terminal point. So basically, the component form for this vector, the horizontal change is 2 units over, and then the vertical change is 3 units up. It's almost like slope, except instead of doing y over x, we do x comma y, like it's an ordered pair. And then we use these weird brackets. They're not exactly parentheses. They have a little point to them, kind of look a little like the ends of arrows. Okay, and x would be the change in x, and y would be the change in y. So in my vector over here, the component form is 2, 3. Okay, and I always recommend graphing this out. It helps a lot because all you have to do is count the boxes. However, if you want to, you can take the ordered pair for D and subtract the ordered pair for C. And you would just line up the X's and subtract them, and then line up the Y's and subtract them. And you'll see that in our next example. Okay, the other thing I need to mention is how we name vectors. It's just like naming a ray. You would name the initial point first and then the terminal point. And it almost looks like it has an arrow on top, except it's only half an arrow. Okay, and if you want to, you can zoom in and see it there, but that's how you would name a vector. So let's take a look at an example. In example 1, they want us to write each vector in component form. So in part A, they graphed the vector for us. And remember, component form looks at the change in x and the change in y. And we always count from the initial point to the terminal point. So E is initial and F is terminal. So see if you can find that change and write the component form, and then press play to see if you're right. I counted from E to F. It went 1, 2, 3 units down and 1, 2, 3, 4 units over. Okay, so the X change was 4 and the Y change was -3 because it went down. And it works just like when we're graphing. If you go down, it's negative. If you go up, it's positive. Okay, so that was it for this example. For the next example, they want you to find the component form of vector PQ. And they gave you the initial point P is 7, -5, and the terminal point Q is 4, 3. So in this one, we have to do a little math, or you could graph it and then see what you get when you count. So try and find the component form and then press play to see if you're right. So I chose to do a little math, and it's just subtraction, so hopefully I'm okay. So we have the terminal point, and I wrote out the x and then the y. And then the initial point, and I wrote out the x and then the y. And then all I did is I subtracted in my columns. 4 minus 7 is -3. And 3 minus -5 is 8. So my component form for this vector is -3, 8. And that's it for this. So you have a check it out question coming up next. In check it out number 1, they want you to write each vector in component form. In part A, they want you to find the component form of vector u, which is the graphed one over here. And in part B, they want you to find the component form of the vector with initial point L, which is -1, 1, and terminal point M, which is 6, 2. So go ahead and do that, and then press play to see what we have next. Now that we know how to name vectors and how to find their component form, we're going to talk about how to describe different aspects of them. You may remember that I said a vector has both magnitude and direction. So let's look at what that is and how we can calculate each of those things. Magnitude is actually the length of a vector, okay? And vectors often represent speed. So the magnitude of the vector is actually the speed of the object. And to find the magnitude, we're going to use Pythagorean theorem. Notice when I graph my vector and I write out the horizontal and vertical components, this makes a right triangle. The base is 2, the height is 3, and we want the length of this vector. So using the Pythagorean theorem, I can calculate that. Just 2 squared plus 3 squared, and then I have to do the square root to find the length of the hypotenuse. So in this case, my magnitude is the square root of 13. For direction, I need to find the angle the vector makes with the horizontal line, and it's always the positive x-axis. So we would pretend that point C was right where the x and y-axis cross at the origin. And then we need to measure the angle up from the x-axis. Okay? Now, if my vector happens to be down here, I would have to measure all the way around. So when I find that angle, I would have to do some subtraction with 360. So I have to think carefully about which quadrant my vector happens to be in. But to find the angle, we're going to use trig functions, specifically the tangent function, because generally with vectors, we know the vertical component and the horizontal component. And that's the opposite side and the adjacent side. So we would use tangent. And anytime that you want to find an angle measure, you use the inverse function. So I did inverse tangent of 3/2 because it's opposite over adjacent. And I typed it into my calculator and I got 56.3. So let's take a look at an example now. In example 2, I needed to draw the vector 4, -2 on a coordinate plane and find its magnitude and direction to the nearest tenth. Now when drawing the vector, I always just draw a normal coordinate plane, and then I just graph the point 4, -2, and I just draw an arrow from the origin to that point. So this red vector is the vector that I needed. Now we need to find magnitude and direction. So we're going to start off by finding the magnitude. See if you can use the Pythagorean theorem to find the magnitude of this vector, and then press play to see if you're right. To find the magnitude, I took the horizontal component 4 and the vertical component -2. I squared them and added them. Now, I did leave the negative sign off of the 2. And the reason I did that is because we need the actual length or distance that it traveled. And although you could put a -2 in here, a lot of times people do it on their calculator and they forget the parentheses around the -2, and then they get a negative answer for this. But when you square, you always get a positive. So that's why I left off the negative sign, because I didn't want to make a calculation error later on. So 2 squared is 4, plus 4 squared is 16. I got 20 for that. And then I just simplified my square root of 20 to 2 times the square root of 5, which is approximately 4.5. And I got the approximate answer because it said to the nearest tenth. So that's the magnitude of this vector. Now we need the direction. So see if you can turn this vector into a triangle and find the angle that it makes with the x-axis. And then you need to fix the angle because we need to measure from here, from the positive x-axis, all the way around to the red vector. So I need this big angle over here. So see if you can find that and then press play to see if you're right. So first, what I did is I had the opposite side is 2 and the adjacent side is 4. So I did tangent inverse of 2 over 4 to get approximately 26.6 degrees. Now that is the measurement of this angle here, the angle down from the positive x-axis. But direction is measured in the other direction. So I need to subtract from 360 degrees. So I did 360 degrees minus 26.6 equals 333.4 degrees. And that's the actual direction of this vector. I think we need another example of this. So let's take a look at example 3. It says a wind velocity is given by the vector 2, 5. Draw the vector on a coordinate plane. Find the magnitude and direction of the vector to the nearest tenth. So what I did to draw it is I graphed the point 2, 5, and then I just drew this red vector pointing to the point. Okay, now I need to find the magnitude and the direction. Now notice this is in the first quadrant, which is a good thing. So see if you can find both of those and then press play to see how I did it. For magnitude, I needed to find the length of the red vector. So I could use the Pythagorean theorem because this is a right triangle. So I did 2 squared plus 5 squared equals c squared. And I did the square root to get c alone. So the square root of 2 squared plus 5 squared is the square root of 29, which is approximately 5.4. Okay, so the magnitude is 5.4. Now the direction, I needed to find this angle right here that the red vector makes with the x-axis. So I did opposite over adjacent. So I did the tangent inverse of 5 over 2 is approximately 68.2 degrees. And that's the direction of my vector. So you have a check it out question coming up next. I have changed the direction of the check it out questions. In both of these questions, you need to find the magnitude and direction. Okay, in number 2, they gave you the vector -3, 1. You have to draw it and find the magnitude and direction and round to the nearest tenth. In number 3, it says the force exerted by a tugboat is given by the vector 7, 3. You have to draw the vector, find the magnitude and direction to the nearest tenth. So do that and then watch the next video where we're going to talk about equal and parallel vectors and how to add vectors.